You know, sometimes a TV show can explain a really complex real-world idea better than any textbook ever could. And today, we're going to break down how the show Numbers did just that, perfectly illustrating a powerful crime-fighting technique using pure, abstract math to find the home of a serial killer.
So this is the whole idea, right? We tend to think of math as something, separate from our lives. But the show's big argument is that it's a universal language. It can describe pretty much anything, even something as chaotic and terrifying as criminal behavior, by showing us the hidden patterns hiding in all the noise.
Okay, so let's set the scene. The FBI is in the middle of an absolute nightmare. There's a serial rapist who's been terrorizing Los Angeles, and he's just escalated. He's now a murderer. The pressure to catch this guy is at a boiling point, but every single traditional method they've tried has completely failed.
And the scale of this failure is just staggering. We're talking 13 victims. The violence is getting worse, and they have 0 forensic leads. And to make things worse, they are literally drowning in useless information. Over 20,000 tips that have led them on one wild goose chase after another. They are at the end of their rope.
So right when the whole investigation has ground to a halt, a totally new perspective comes into play. And it doesn't come from a seasoned detective or a criminal profiler. No, it comes from a mathematician who looks at the very same case files and sees something nobody else did.
And this is where you see the core conflict, the two big ideas clashing. On one side, you've got the FBI agent Don Eppes. He sees this crime as a deeply human problem, right? It's all about emotion, chaos, unpredictability. But then his brother Charlie, the math genius, comes in and says, nope, everything is numbers. Underneath all that chaos, there is a pattern, and that pattern can be calculated.
So what's happening here is a huge shift in thinking. The FBI's usual method, this predictive analysis, is all about guessing where the bad guy will strike next. But as they even admit, that's totally useless for serial crimes. Charlie's idea is the complete opposite. He says, forget about predicting the future. Let's analyze the past to find the one thing all these attacks have in common: the killer's home base, his point of origin.
So this is where we get into the really cool stuff. How can a bunch of numbers on a page actually track a killer's movements? Well, the theory kicks off with a really simple but brilliant analogy.
Okay, this analogy is just perfect. Think about a sprinkler on a lawn. You have no idea where the next single drop of water is going to land, right? It's impossible to predict. But if you step back and look at the whole pattern of wet grass, you can figure out with incredible accuracy exactly where that sprinkler is. The crime scenes? They're the water drops. The math is designed to find the sprinkler. And this is the really wild part. It's totally counterintuitive. The killer thinks he's being random. He's spreading his crimes all over the map to avoid a pattern. But here's the thing about people. We are terrible at being truly random. In his desperate attempt to look random, he actually creates a different kind of pattern, a more subtle one that the math can pick up on.
And look, this isn't just some made-up TV magic. The technique Charlie Eppes is using is based on a very real method called geographic profiling. It's something police forces have actually used for decades to help narrow down the search in these huge, complex cases.
So, how does the model actually work? Well, it builds in a couple of really key ideas from criminal psychology. First, you've got the buffer zone. The idea is that a killer isn't going to commit crimes right on his own block, because he doesn't want his neighbors recognizing him. And second, there's distance decay. This theory says that the riskier or more intense the crime is, the farther away from his comfort zone he'll travel to do it. These very human behaviors become numbers in the equation.
All right, so the theory makes sense. The equations are all set up, and they plug in the data from all 13 crime scenes. The FBI is desperate, and the math gives them a solid lead. But yeah, this is where things get really interesting.
So the algorithm crunches the numbers and spits out its first MAC. It highlights this one neighborhood in Silver Lake with a pretty stunning prediction. There is an 87% probability that the killer lives right inside this hot zone. I mean, this is the first real lead they've had in forever. It could change everything.
So the FBI goes all in. They throw 40 agents at that hot zone, working around the clock, getting DNA from every single man in that area. We're talking over 50 guys. And the result? Absolutely nothing. 0. Not a single match. The whole theory, the math, this miracle lead, it all looks like a spectacular failure. Just when everyone is about to scrap the whole idea, Charlie goes back and looks at his work again. And he spots something weird. The model matched up with almost all the crime locations perfectly, except for one. The attack on victim number 12. According to his model, there was only a 2% chance that an attack in this series should have happened there. It was a total outlier. So this becomes the most critical question in the entire case. Instead of just saying, the math is wrong, Charlie flips it around and asks, wait a minute, what if the model is right? And what if it's actually telling us that one of our facts, one of our data points, is wrong?
And that is the turning point. It's the moment they realized the algorithm wasn't just a machine for predicting things. It was a lie detector. It was basically screaming at them that the information they fed into it was bad. The problem wasn't the math, it was the input.
And that question leads right to the big breakthrough. It's the classic computer science problem, right? Garbage in, garbage out. An algorithm is only as good as the data you give it. And that little 2% outlier was the key to finding the garbage that was throwing the whole thing off. So what was the garbage? It was a lie. A very human lie that almost let a killer get away. Victim number 12, Karen Silber, had lied to the police. She told them she was attacked in one place, but it actually happened somewhere totally different, near her ex-boyfriend's house, a place her fiancé had made her promise she would never go again.
So once they get the right location for that one attack and plug it back in, wow, the results are just staggering. The probability shoots up from 87% to an incredible 96%. And even better, the new hot zone is way smaller, way more precise. It narrows the search down from over 50 men to just around 20.
And that's the real lesson here, isn't it? The math did way more than just find the killer's address. Its most important job, in the end, was to find the lie in the human side of the investigation, that one piece of bad information that was keeping the truth hidden.
And that's what makes this whole thing so fascinating, right? It's just a great reminder that under the surface of our world, which can feel so random and chaotic, there are these deep patterns and structures that math can help us see. It really makes you wonder, if we can just figure out the right way to look at the numbers, what other incredible truths are just sitting there,